Hey everybody, this is Larry. This is November 16 here on Saturday, really early morning, right after midnight. I haven't done this in a while because of marathon training. I know that I've been kind of using it for everything excuse, but really it was a huge just drain on my body. So today let's take a look at a random problem. I haven't done a random problem in a while, so let's do a bonus one. So especially since today's daily problem I did like a couple months ago, so it was way fresh, I suppose. But yeah, let's take a look. We have 1628 design an expression tree with evaluate function. What for this thing? So I don't know what's going on, but okay. Postfix is a thing. Okay, you have a node class that you implement the expression tree. What is going on? We'll look at the follow up later, but so. Okay, so we have plus minus, so we have the four operations, right? Okay, and basically we're trying to, there are two functions, a postfix string and node. I don't know what the node is for. Build tree, I guess build tree just calculates the node. For the binary expression tree. Okay, I mean, let's think about this. What does a postfix? So basically, we have to convert a postfix to a tree, right? So what does a postfix mean? So okay, so that every so the way that I usually implement this is with a stack. So I have to kind of think about how does it relate to a tree, honestly. Yeah, I mean, every operation, right, it's going to be, so yeah, I mean, the first observation, and maybe this is already in there kind of actually, honestly, each leaf node is going to be numbers and the operations are on a thing, so we just have to figure out that way, right? So okay, so the way that I would implement it in a stack is just push numbers and then kind of do that. So then now we can maybe construct the nodes that way, even though it feels a little bit awkward, kind of, because I feel like I'm doing it like I don't know if there's a more native way of doing it, but the way I feel like I'm doing is that I'm doing like, instead of like they want me to convert from A to C, but I'm converting from A to B to C to B to evaluate kind of thing. So that's why it feels a little bit awkward, but okay. So yeah, so let's say we have a stack, right, and maybe this could be whatever, and then we have for X in postfix, right? So we have if X is in plus what's it, the other one, subtract, right? Then this is an operation, and then we want to make this a node, right? So we have a node. I'm trying to read what the interface means, but basically we want a new node of the previous two things, right? So maybe stack will actually contain nodes. So here, right? Else this is a number, and then we want a new node of X, right? Something like that. And maybe we have like a thing that is to indicate it is like a number. Maybe it's a forceful operator or something like this. So maybe we can have something like what we call it, right? Is maybe X and then is operator or something like this, right? And then yeah, and then maybe just solve that X equal to X, solve that is operator, you go is operator, something like that, right? And maybe we can even convert this to int. I don't know. I mean, I think it's not that interesting of a detail, but then we just put this on stack, right? And then now if this is an operator, then now we want to put X. It is true that it is an operator, but now we want a left and a right, right? I actually missed this. Left is equal to none, and I don't know. I mean, you can actually probably even put this in the constructor, so maybe we can do it this way, right? So we can do left equal to none, right is equal to none, something like this, right? Yeah, and then here, then now we have, I think we have to be a little bit precise, because for addition and multiplication doesn't matter, but obviously for subtraction and division, it matters. and the top of the stack is going to be on the right side. Yeah, right. And we should assert that stack contains at least 2 elements. Right. Otherwise, we're really wrong. So we have these 2 things. Actually, maybe the way that I would write it is that we have B is equal to stack.pop, A is equal to stack.pop, and this actually includes, like, they both should be nodes, right? So now you have A, B, right? And then we could push this back into the stack. And really, that's it, I think. And then now at the very end, we should have, I think we should have only 1 element, right? So let's assert that to make sure that we're correct. And then we can just return stack of, what's it called? Well, I guess 0 and -1 because that's 1 element anyway. And then return the node. Okay, and then now we have to also implement evaluate, right? I mean, also for now we're just kind of focused on the nodes, but you can actually have subclass. I guess I'm just reading up the follow-up, but okay. Actually, let me skip the follow-up for a second. Let me finish the actual problem before we do the follow-up to the problem, right? So you evaluate. So then now if self dot is operator, okay, then okay. If it's not, then there's a number and it's a leaf. Then we just returned self dot x, and it should already. We already converted to an int. Otherwise, then now we have to do something like, and this is where maybe you can subclass an operation node, but since we didn't do that, and that's fine, we can do a switch statement for now, right? I actually don't know the switch syntax, so I'm going to Google that real quick, because it's still relatively new, and every time I say this, I'm trying to learn it, so that's why. Okay, match. That's right. It always feels a little bit awkward, but okay. Yeah, so I'm still trying to make it so that it becomes muscle memory, right? And this is how you learn new things, or that's how I learn new things, right? So if it's plus, we return self dot left, or dot evaluate plus self dot right dot evaluate. Yeah, and maybe you could even just write something like left is equal to right? So just make it slightly. I mean, I don't think it's a performance issue, but yeah, return left plus right. Case right? We return left minus right, and so forth, right? Is division integer division? If so, then maybe I messed up anyway. Let's do integer. It doesn't really say. Let's do integer division for now, and then we'll figure it out. I mean, it really don't. It's either right or wrong, I suppose. But yeah, and then we assert false because it has to be one of these things, right? So maybe default or something. We're gonna assert false as well. Whatever, right? It's either default or is it case underscore or something. I might be wrong on that one. I already closed my window, so if it complains, we'll figure it out. It's fine. Yeah, I think it's this. Like that feels more Pythonic as a result. But oh, am I supposed to subclass this? I don't know what's going on. This infinite. You should not remove it, and you can do some classes to implement it. Okay. No, whatever. I'm already using ABC. Self.x match self.x. I'm too lazy to go. I mean, I already kind of did, but I mean, I guess I should have subclassed it. But whatever. Let's see if that works. Let's go quick submit. Looks okay. I mean, so yeah. So I think the thing that you can also do is, and this is probably a little bit more specific to this problem that I would like for the follow-up is what I'm talking about. Can I make it more modular, right? And the answer is yes. We can probably put, I mean, the thing is that it's still a little bit tricky because then now you have like builders and stuff like this, and you would just put the same logic but in the parsing thing, which maybe is still cleaner. I don't know. These are things that are kind of a little bit more subjective, but in that case then you have like a multiplication operator load, addition operator load, node, and so forth, and then then you don't have to have this match statement or switch statement, and you just kind of like return these things, and whether like you have a number node as well. So you can definitely do things that way. So that definitely this way is probably not as modular as possible, but I'm a little bit lazy, so I guess it is what it is. Yeah, because you can imagine. Wait, this give me the complaint. Yep. So then you can imagine something like like number node, and then you just have like right, and then now you know that this is going to be x, and then you have like, I don't know, addition node, for example, or some addition node, right, and then it would look like some and evaluate would just be return self.x, for example, and addition node would be like, and then it just contains node to left and right, and it really should not be none, honestly. In this case, it should actually be something, right? Because if you don't have numbers, then you're not adding. And then it's just self.left is equal to left, self.right is equal to right, and then evaluate self is going to be self.left, what's it, plus, oh, whoops, dot evaluate plus self.right dot evaluate, right? Something like this, right? And then you obviously just do it for the rest. I'm not going to finish typing this idea out, but that's really the idea, right? Like you do it for each one, and then it's just about, putting the logic into the parsing node and putting into the right nodes. You can do things about like filters and adapters if you really want to get playful, but those are kind of the ideas that I would play around with object-oriented stuff. But yeah, I mean, this is honestly pretty straightforward version of like OOP things. So anyway, that is all I have for this one. I mean, this is going to be linear time, linear space. We look at each node once. We create one node per thing, right? So there's going to be linear time and linear space. And yeah, that's all I have for this one. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.